Recording. Okay, so I hope everyone kind of remembers whatever we discussed yesterday. If not, it's fine. We can revise that today. But this is the topology that we have. Okay, if you want, you can take a snapshot. But yeah, so we have this two leaf, which is an MLAG. So this is a routing VTEP. Okay, and this one is a bridge, which means there is no SVI here. And this is a standalone VTEP, which is also routing VTEP, and we have this hosts connected. Okay, so this is in 100 subnet that you see. This is VLAN 100, like that same. Okay, this is VLAN 200, and this is also VLAN. This is VLAN 100, I think. Yeah, 100.1.1.200. Okay, so what this is what we're going to cover today. So first off, we'll start off with IP address virtual, and in IP address virtual, we'll see the following. First, we'll see about the ARP headers with encapsulation. Okay, ARP request headers. Okay, then we'll see about ARP sync, both VXLAN and MLAG. We'll see how the behavior changes with and without VVTEP. Okay, so just remember this topology. Leaf 1 and 4 is an MLAG. Okay, and if you see here in this lab, so leaf 1 and 4 are adjacent, so they are MLAG. Okay, leaf 2 is bridging VTEP. This is again leaf 1, which I opened for TCP dump, and this is leaf 3, which is also a routing VTEP. So I'll just show you the config once. So it has the VVTEP configured. Okay, and this is MLAG, so it will have the exact same config. So same VTEP IP, VVTEP. Okay, we have the VNIs, and we have 100 and 200 SVIs, which has IP address virtual. Similarly on leaf 3 also we have VVTEP, and we have the SVIs here also. Okay, and we have the virtual MAC. So I'll just do this. Show the virtual router MAC. Okay, so we have the virtual MAC present here on the routing VTEPs and here. Okay, so this is bridging, so there is no routing VTEP here. There is no VMAC configured here. So first thing, let's see how the ARP request looks like, right? So if you remember, I told in with IP address virtual, right? Everything is virtual. So so let's say we are trying to ping the locally connected host. So the host that is locally connected is host 1, right? So we'll try to ping host 1, which is 100.1.1.100. So I'll just clear this. So, okay, let's run the capture here. TCP dump, interface 100. Okay, ping 100.1.1.100.
Is it a real lab or a
This is VOS, ACT. Yeah, I mean, hardware we don't really need, like unless anything that's related to understanding the concept, we can do it with this. So I didn't bother about hardware that much. But you can.
Okay.
All right. So now, if you see here, what do we see? We see that the source MAC is actually physical. Okay, which is the physical MAC. Okay, but if you take a capture here, clear our cache. Oh, sorry, it's not VLAN 100. This is it the right interface? Oh, it's port channel. Okay, speed down. Okay, let's clear again. And here, if you see, ARP request, it is a VMAC. Okay, so what happens is when in the kernel, when it generates the ARP request, it it generates with the physical MAC, but when it actually egress out, when it goes to the DMA driver, it again rewrites that packet and it changes the source MAC. So if you're on call with customer and let's say you did a you know that hey in IP address virtual everything is virtual, right? So and then you did a TCP dump and you see that the source MAC is physical MAC, so don't be surprised. So when the packet actually egress out, and in fact, if you take a TCP dump on the uplink interface, you should see um, you should see the encapsulated packet has the the inner source MAC as a VMAC. So let's do that. I think we can take it on. Yeah, we can just take it here. TCP dump 4. Let's see. So where is the VXLAN ARP? Here it is. And if you see here, the source MAC is VMAC. And what is the outer source IP? It is a VVTEP IP. Okay, 5555 is a VVTEP. So when as I mentioned, right, if the inner source MAC is VMAC, the outer source IP will always be VVTEP IP. So no confusion here. Any doubt? It is straightforward.
Akshay, Aniket, sorry.
Yeah.
I just confused over there.
Mm-hmm.
A request sent me like you're saying that when we initiate the request, it will go with the physical MAC initially, and then it will get rewritten uh, after. I mean, like some
Yeah.
agent
So
rewrites the yeah,
yes. So see, when I initially did the TCP dump in VLAN 100, which
right,
is a
yeah,
kernel interface where the where the ARP request is actually generated. Okay, so
correct,
the kernel when
yeah,
it generates, it creates a packet with source MAC as a physical MAC. But there is a
okay,
pipeline where the packet goes through. Okay, and one of the pipeline where it goes through is it includes a DMA driver where the packet is again rewritten. Okay, in that the
okay,
packet is again rewritten with the source MAC as a VMAC, and that is the actual packet which gets encapsulated. So
okay.
after that, the packet gets encapsulated with the source MAC as a VMAC.
Okay, but when kernel generates it, it would
Yeah,
show only with the physical
yeah,
Mac. So,
yes,
so I think when we do captures, we should not capture it in the
yeah.
VLAN 100. Rather
You
than we
can.
should,
The
yeah.
only reason I mentioned this is so that you're aware, right? Because you can take a capture, but as long as you know that, that is fine. And when the
Fine.
source MAC is
Okay.
going to be VMAC, it is okay, right? It's just for your awareness I showed this. Okay, but
Okay. How about the reply we get? That would be from for the physical Mac, or it would be for the virtual Mac.
so if you see here, this is the reply that host is sending, host one.
Yeah.
Okay, so it got the ARP request with the source MAC as VMAC. So it will always send the ARP reply destined to the VMAC again, right?
Yeah, yeah. But I'm saying about when we do a
Oh,
capture
yeah.
at
Okay.
VLAN 1,
Then
yeah,
it'll be then it'll be VMAC. Yes, that's right.
it will be virtual Mac only.
Yes, let's see that. So we'll start the capture here. And what we'll do is we'll clear the ARP here. So we should send an ARP request. Oh no, it's again physical MAC. But if you take the capture here, I mean, if you see the ARP, it'll be VMAC. And if you take a capture, I'll just log into this host again. Okay, so okay, let's run a capture here. TCP dump interface port channel 1, and let's clear the ARP. Yeah, again, same thing basically. In the kernel, we saw uh, on leaf one kernel, we saw the ARP reply source with physical MAC. But when it actually goes out, you will see that the source MAC is physical MAC. Source MAC is VMAC.
Virtual. Okay.
Yes. Okay.
Okay. When reply comes from the server, it would again point as physical Mac.
This replies from the switch, from the leaf.
Okay, you're bringing from the host towards the leaf, is it?
I just cleared the ARP, so it'll send an ARP request because it has a static route with the next hop
Okay,
as the gateway. Okay. So if I just clear the ARP, it will send an ARP request. So I just cleared the ARP and host one sends an ARP request. And what we see is that leaf one sends an ARP reply with the source as virtual MAC.
okay. The same thing in the leaf perspective, it would receive it for the physical MAC and send the response also from with the physical MAC, and it get converted
Converted
once
into
it gets
VMAC.
out into
Yes.
VMAC. So what is the
Yes.
best place we can actually see this? Is it only through mirroring, or we can see through uh, the uplink ports or something? Okay, I mean like any other
We
ports apart from VLAN, we can see this, right? The
you
actual,
want to you want to see the VXLAN ARP request that is sent by the
yeah,
switch, or
because it's misleading, right? In the kernel, it could
yeah.
confuse. Yeah. So which is the
Yes.
best place to I mean like to see the actual
So
packets?
So generally speaking, in hardware also, whenever the switch generates a ARP request, okay, you can
Okay.
just take a normal TCP dump on the uplink. You don't have to do mirror also in
Okay, just the
hardware.
uplink.
Yeah,
Okay.
just the uplink. If you take a mirror, just if you just take a TCP dump on that uplink that is connected to spine, you will see the
Okay.
encapsulated ARP there.
Okay. Yeah. Thanks.
Encapsulated ARP request. Okay,
Okay.
okay. But there is a catch. You will not see ARP reply. You will not see encapsulated ARP reply. That is
Because it
weird
goes
actually.
to some other
That
leaf.
that is because that reply is sent by the VXLAN software forwarding agent, so that
Okay.
doesn't go through the kernel. So you won't see it in normal TCP dump, which is a bit weird. But that's kind of a limitation we face. Like if you let's say you want to see a ARP reply that is being sent by a leaf, right, on VXLAN interface,
Correct.
you will
Yeah.
not be able to see that in normal TCP dump. You have to mirror it.
Okay. There won't be ARP reply going out of this VLAN if we do that.
Yes, correct. I mean, if you do TCP dump, and in fact, I can show that. I'll show that later. If I do a
Okay.
TCP dump interface VLAN 100, right? And let's say
Okay.
there is a remote host that is sending an ARP reply here, you will
Mm-hmm.
not see that. Sorry, it's sending an ARP request. You will not see the ARP reply being sent here. Okay, so let me show you. So host 3 is a remote host. Okay, this is a remote host, and what I'll do is, um, actually, no, I have to do it from host 2. Let me do it from here. Actually, we'll get to that later, okay? Because then it'll be more confusing if I go into that.
Yeah.
Uh,
Yeah. Yeah.
for
Yeah. Sure.
now, for now, all you need to know is whenever we are sending the ARP request from this leaf, it in the TCP dump, in the VLAN TCP dump, you will see that it is physical MAC, but when it actually goes out, it will be virtual MAC. Is that clear with everyone?
Aniket, could you repeat the last line you just said?
Yeah. So what I'm saying is, if you take a TCP dump here, VLAN 100, and let's say I clear, this is again leaf 1. Okay, this bottom
Yes,
device is also leaf 1. If I clear the ARP and if I ping 100.1.1.100,
it will
you
ask.
will see that the ARP request is sourced with physical MAC here.
Okay.
But
Uh-huh.
when the packet actually comes to the host, right, it's actually VMAC. So you see this ARP request.
Mm-hmm.
Um, where is it? Yeah. So it will be virtual MAC here. Okay, so when the packet actually goes out from this leaf, then it's that source MAC is rewritten.
Okay.
So whatever I explained yesterday, right, that in IP address virtual, the source MAC is virtual MAC, that is true. That's what I'm trying to say. It's
Correct.
never
Correct.
physical. Okay, so just remember that part. And if
Aniket,
you,
just to uh, uh, final query. Sorry,
yeah,
it
yeah,
took a
yeah.
long time. So this VX1, if I mirror that port, will it give me a clear picture? Because that should be giving the proper MAC address, right? Or
So here, if you take capture on this interface, you will see, but I
okay,
don't think we see this interface in hardware. I need
we
to
have
check that.
VXLAN, right? VX1 interface, right?
We have VX1, but I've never tried that, honestly. Few
Okay.
few versions back, we didn't used to have this VX1 interface,
Okay.
but
Okay.
we can check that later. Okay, that is
Yeah.
fine.
Sure. Fine. Yeah.
For now, let's understand how that ARP packet goes out and what information it has.
Okay. Yeah.
Okay, about the capture, we'll discuss it again later.
All right. Yeah.
Okay, so this part is clear. Any questions? Okay, so now what we'll do is we will check about um, we'll check the we'll check how this ARP request changes when VWTIP is not present. So if you see here, we have the VWTIP configured here. Okay, and let's say on host 2. Okay, I'll just log into host 2 again. Okay, so what we'll do is host 2's gateway is 200.1.1.1. Okay, if we check show IP route 200.1.1.1, that's its gateway. So I'll just take a TCP dump here. And I'll clear the ARP. And what you see is, you will see it sends an ARP request and it gets an ARP reply. Okay, host 2 is connected to a bridging VTEP. If you remember the diagram, this is host 2. It's connected to leaf 2, which is bridge. So when it sends an ARP request, leaf 2 is flooding that ARP request to what IPs? It is flooding to 1111, 3333, and 5555. So whoever is getting that ARP request destined to 5555, only that VTEP is responding. Now what we'll do is we'll remove this VTEP and then we'll see what happens. Okay, so we'll go to this. This is how the VTEP is configured. I'll just remove this. And leaf 3 is also routing VTEP. So I'll remove it from here also. Now let's go to the host and let's do the same thing again. And now what you see is there are two ARP replies. Okay, because now what is happening is when host 2 sends the ARP request, it is getting flooded to 1111 and 3333. And since they don't have the VTEP, they are both are responding. But once we configure the VTEP on the routing VTEP, they will only respond if they get the ARP request destined to 5555. Is this clear?
Okay. This is the reason we get duplicate packets in ICMP. Is it?
No. That is different, separate thing. This is
Okay.
duplicate thing that can happen due to flooding.
Okay.
So now I configured the VTEP again, and now again you will see only one ARP reply. So this part is clear, right? When VTEP is not configured, what happens? And let's say one scenario could be like I have the VTEP configured now, and what happens if I go to leaf 2? I remove the VTEP from the flood list. Okay, this is leaf 4. Sorry, leaf 2, this is the bridging VTEP, and I remove 5555. Let's say, what will happen? Can anyone guess? If host 2 now tries to resolve ARP with its gateway, what will that work?
So we removed it from leaf 2, is it?
Yes, leaf 2 is a bridging VTEP where host 2 is connected. And host 2 sends an ARP request for its gateway, and 5555 is missing here.
Yeah, it would
if
give the
VTEP
ARP
is
request. It will get the ARP reply from one of the VTEPs.
Who agrees to that?
I'm sorry.
If again leaf 1 and 3 is configured with PVTAP, it's you're not gonna get a ARP reply, right?
Yes, they are configured with VVTAP. So all they will get is, sorry, I think it is missing here. Let me add this back. Yeah, it is present here. Okay. So on both leaf 1 and leaf 3, we have the VVTAP. And now if they receive the ARP request, they will only receive it with their physical VTAP IP. So will the ARP get resolved?
No, ARP
Not
replies only sent.
Okay, let's confirm. Just a second. I hope I added it here. Okay. So host 2, right? Yeah. I will clear the ARP now. And you can see ARP is not getting resolved. Even if I try to ping, ARP will not be resolved. Okay, that's because now the ARP request is only getting flooded to these IPs. And since these routing VTAP are configured with 5555, they are not responding. So we need to add that 5555 in the flood list. And now the ARP will be resolved. Raja, is it clear? And others?
Yeah.
So this behavior is seen in both the PARP and IP virtual, right?
This
Virtual
behavior
IP.
is, yes, that's correct. It's with both VARP and IP virtual. It's
Okay.
just that in VARP, they get the all the VTAP will send a GARP packet, the HTTPS ARP, right? So generally you won't see that the host is sending an ARP request also. So in that case, it just works. Like there is no need to send an ARP request. Anyway, but you're right. It's the same thing in VARP also. Okay. Okay, now what I hope this part is clear, then we'll go with the synchronization part. Okay, first we'll do the ARP sync with the VXLAN. So what we'll do is we will send an ARP request from host 2 for its gateway, okay, which is 200.1.1.1, and we will force, sorry, my bad. We will send an ARP request from leaf 1 for host 2, okay, and host 2 will send that ARP reply destined to the VMAC, and we'll force that ARP reply to go to leaf 3. So how will you do that? We'll remove that network command 5555 from here. So we'll go to leaf 1. So I will remove this. Okay, so now on the spine device, the route to 5555 is only pointing to leaf 3. So we'll force that ARP reply to go to leaf 3. Okay. If at any point I'm going fast, please stop. Okay, and please just ask me to go back. Okay. So now let's try to do the ping. We'll first clear it. So we'll try to ping host 2, which is 200.1.1.100, I think. Yeah. Finish. And parallelly, this is leaf 3 where you will get that ARP reply. We will run that capture here. We'll take it on this interface. And let's filter for port 4789. Okay, now we have cleared the ARP, and also let's clear the MAC address table. Okay, now let's ping 200.1.1.100. Now, what we see there is an ARP reply. Where is it coming from?
The bridging VTAP.
2222. Leaf 2 is bridging VTAP. Okay. Who is the source MAC? 0B89. Whose MAC is that? That has to be host 2.
2, yeah.
0B89. It is destined to the VMAC. This is correct.
Yes.
And this is the ARP reply. Now, if you see that same ARP reply, okay, it's getting flooded to 1111. And you will see the same ARP reply here. See. And what you will
Source.
see is the source
Source.
MAC is now different. C2.
Yes.
Whose MAC is that? C2. It's its own MAC.
VTEP 3, yeah.
So it changes the source MAC to its own MAC and then it floods that ARP reply. Due to this, when you will see the ARP here, you will see it as not learned. Not learned. But if you see here, the MAC is learned. This is the ARP reply sync behavior.
Yeah, Aniket, can you just reiterate this part alone?
Okay, so this is what we did. Okay, we are pinging from leaf 1 to host 2. Okay, and while doing that, it is creating the ARP request source with the VMAC. So host 2 is sending the ARP reply destined to the VMAC, correct? So the DMAC here is VMAC. And that ARP reply will be encapsulated and we are forcing that ARP reply to land leaf 3 because it is encapsulating with 5555 DIPS 5555 and on spine the route to 5555 is only pointing to leaf 3, right?
Okay.
So we took a capture on leaf 3 and what we see on leaf 3 is we see there are two ARP replies. So one is the original ARP reply. If you see this is the original ARP reply that's coming from the host. So this is the host 2 MAC who is sending the ARP reply destined to the VMAC.
Okay.
And that is coming from leaf 2, 2222.
Correct.
And that is getting synchronized or that is getting flooded to 1111. Okay. And you will see that the inner source MAC is now changed. Okay. So it is flooding that ARP reply, but it is changing that inner source MAC to its own MAC.
This leaf 2 is itself is generating, you're saying.
It is just relaying that ARP reply to all the VTEPs. But when it is doing that, it is changing that source MAC, inner source MAC to its own MAC.
So when VTEP 1 receives this packet, shouldn't
Yeah.
it learn it as VTEP 3's MAC address?
So
How does
this
it know
information,
that it is?
so
Yeah,
here if
go
you
ahead, go
see, right, in the ARP reply, the reply in the ARP header, this is the host 2 information. This is not VTEP 3 information, right? So the ARP information is intact. That is not changed. Only the Ethernet source MAC is changed. Right? The ARP information is same. So when VTEP 1 or leaf 1, when it will get that ARP reply, it will learn the ARP because of this information, which you can see here. 0B89. Whose MAC is that? That is host 2. But is this MAC learned anywhere in the MAC address table? That is no, it is not learned. That's what
Yeah,
it means
my
is,
question is how does it know that it is coming from that other VTEP and it is a VTEP, I mean the ARP sync information.
it is leaf 3 is flooding it, right? It is sending it to leaf 1. If leaf 1 gets an ARP reply, it is going to learn it. Sorry, I'm not understanding your question actually.
So my question is now VTEP 1 has received the ARP packet
ARP reply.
sent by VTEP ARP reply sent by VTEP 3, right?
No, the ARP reply is from host 2. Only VTEP
No,
3
but
is doing
this
is
is
it is
sync one.
sync. It is change. Only thing VTEP 3 is doing is it is changing the source MAC, Ethernet source MAC. The ARP information is not changed. Inside the ARP payload, right? That information is not changed.
Okay.
Okay, so when you are sending an ARP reply, you have two headers, right? One is the ARP header and then you have the Ethernet header. Inside the ARP header, you will have the sender IP, sender MAC, target IP, target MAC. Those information is not being changed. The only information that is changing is the source MAC in the Ethernet header.
Okay, got it.
So that's why you're not learning the MAC address, but you're learning the ARP.
So,
Can you want us to show VXLAN address table on leaf 1?
Yeah.
so usually the ARP header MAC and the Ethernet header would be same, right? In case of
Generally it is
VXLAN, it's
same.
just the
Yeah,
okay.
generally it will be same. And that's why
Okay, got it.
you will see that it has learned. But in this ARP sync, we are changing the source MAC, inner Ethernet source MAC. Because of that, we can learn the ARP, but we can't map that MAC address to an interface.
But
But we learn this MAC address.
yes, in
And this
VXLAN
MAC
1.
address, yes, and this MAC address of leaf 3.
Yeah, but why is it not being shown in the VXLAN address table?
That is timed out, nothing else.
Okay, timed out. Okay, cool.
Yeah, I can do it again. Okay.
Yeah. Yes, got it.
Hey, Aniket,
Yes.
this one part I was unclear about the two MAC addresses. The second MAC address I could understand because of the ARP sync. What about the first MAC address with the host, the actual ARP request? How did it, I mean, like, doesn't the local, the bridging VTAP flood it with its, I mean, like, how come the MAC address of that one is not changed?
So let's see here. Okay. This host is sending an ARP reply destined to the VMAC.
Correct.
So
Yeah.
when leaf 2 will encapsulate, what will be the information in that? What will be the outer source IP?
Outer source IP would be the host
Two-
IP
No. Outer source IP is 2222, which is VTEP's IP
after encapsulation.
after encapsulation.
Okay, 2222 and destination will be for 1111 and
No, this is ARP reply,
destination
right?
for 5555. Yeah, 5555.
Here the VMAC is mapped. VMAC is mapped to 5555. How? Can anyone answer how this is learned? When is it learned? Come on. How are you learning this MAC address? VMAC pointing to 5555 on leaf 2.
Because it's the ARP request.
Yeah,
Because
because leaf 1 is sending the ARP request, right? With the inner source MAC as VMAC and
Yes.
outer source IP as 555. So we will learn it. So when host is sending the ARP reply, it is sending it to VMAC and VMAC is pointing to 5555. So the outer DIP will be 5555. Okay. Now this packet, right? And behind this, we have the ARP payload. We have the inner source MAC and inner DMAC. Okay, and behind that we have the ARP payload, ARP reply from H2. Okay, here the inner source MAC is of here the inner
Host,
source MAC is host
the host
H2
MAC.
and DMAC is VMAC. Correct?
Right. Yeah.
Now what happens? You tell me. This ARP reply comes where?
That reply goes to 5555. Spine leaf 3.
It goes to leaf 3 because on spine it is only pointing to leaf 3, the route to 5555. On spine, the route to 5555 is only towards leaf 3.
Okay.
So this complete ARP reply packet lands on where? On leaf 3.
Leaf 3.
That is what you see here. If you see the capture, this is the ARP reply. This is the ARP reply. Okay. You can see this part is the reply 200, 100, 100 is at this is the MAC address of H2. And
What is this MAC address? 0B89.
this is H2's MAC address, right? It is sending.
Okay, the outer source MAC is also the H2's MAC in the encapsulation.
No. See, here, this is the outer MAC. Sorry, this is the outer MAC. Okay, this is the outer source
Okay.
IP, destination IP. This is the
Okay.
inner MAC, inner header.
Okay. That's the inner MAC. Okay. What is the okay. Yeah. Please proceed. Proceed.
Is it clear?
Okay. This is the inner MAC, which is the actual H2's
Yeah,
host, and this thing never changes, I guess.
this thing changes, right? See, the next line, if you see this is changed. See the source MAC here and here.
Okay. You're saying that the R payload inside it's changed.
No. See, this is the ARP reply it is getting, right? And when
Correct. Yeah.
it is relaying this MAC, when it is relaying it, it is changing the inner source MAC from H2's MAC address to leaf 3.
Okay. That is the inner source MAC is the thing which is inside
Yeah,
the R payload.
that is not inside ARP payload. This is Ethernet header.
Okay. Ethernet header.
You're
Okay.
confusing between Ethernet header and ARP header.
Okay. Okay.
Okay, this is ARP header, this is Ethernet header.
Okay.
Inside the Ethernet header, this source MAC is changed. Inner source MAC is changed to leaf 3.
Okay.
Because of that, on leaf 1, you learn the MAC address of leaf 3, right?
Okay.
We see the leaf 3's MAC address,
Okay.
B8C2. But you will not learn the MAC address of H2 here, because here the inner source MAC is changed.
Okay.
And why is it changed? If it's not changed, if it is H2, then on leaf 1, you will see that H2 is pointing to leaf 3. Is that correct?
No, that's wrong. Yeah. So
Yeah, that's why it is changed.
so when we are using when an R sync is happening for a bridged VTAP, it would always be a not learned is what we understand.
Not always. On some VTEP it will be learned, some VTEP like the VTEP which will receive the
Leaf
ARP
3
reply,
it
it will
will be
learn it.
learnt. Okay.
If the
Okay.
same ARP reply goes on leaf 1 and leaf 4, okay, they will
Okay.
learn it. They will learn
Okay.
the MAC address, and they will also sync it. They will also flood it to leaf 3, and on leaf 3
Okay.
then you will see not learned.
Okay.
Anyone else? Any other doubt? Is it clear? Are we good?
So again,
Yeah.
for VR, do we have this ARP sync?
No, there is no ARP sync in VR here.
So let's say we have a similar scenario where leaf 1 and leaf 4 is not part of the routing. Spine 1 does not recognize leaf 1, leaf 4 as part of the network as 5.5.5.5. The network command
5.5.
is
No. So in VR, 5.5.5 will not even come in the picture, because when leaf 1 will send the ARP request, it will source it with its own unique physical MAC. So the outer source IP will be 1111. So the ARP reply will always come to leaf 1, who is originating.
okay. Got it.
Only in case of IP address virtual, it is sourcing it with virtual MAC, which can go to leaf 3. So that's why you need the sync here.
But
Any
while encapsulating, it would have it as 5.5.5.5, right?
in which case? In VARP?
After the ARP is resolved, yes, in VARP. After the ARP
No.
is resolved.
If inner, what did I told yesterday? If inner source MAC is physical MAC, the outer source IP is primary VTEP IP, not VVTEP. So when it is sending the ARP request, if the inner source MAC will be its own unique physical MAC. So the outer source IP will be its physical IP, not 5.5.5.5.
No, not for the ARP packet. I mean, for the, let's say I'm sending a ping from host 1 to host 2, and after the ARP is resolved, the ICMP packet, it would be encapsulated with
Physical MAC.
5.5.
No,
Physical.
it will be the inner source MAC will be physical MAC.
Okay.
Okay, we'll see that. So for now, at least this VXLAN ARP sync part clear. How this ARP reply going to leaf 3 and how leaf 3 is changing this inner source MAC and how it is flooding into leaf 1 and how leaf 1 learns that ARP but it doesn't learn the MAC address of host 2.
Just one more query, Aniket. So, ARP sync will happen when the request comes from VVTAP.
ARP sync happens when this host 2 is behind a bridging VTEP. It's a very specific scenario. You see this host is connected behind a bridging VTEP.
Correct. Yeah. How does the leaf 3 identifies that it should do the ARP sync based on
If it gets a ARP reply, so that's
okay.
what I had written here. If leaf 3 gets a VXLAN ARP reply with inner DMAC equals to VMAC and outer DIP as BVTEP, it will always do ARP sync. Or not just leaf 3, any routing VTEP. And why I'm saying VXLAN ARP reply means it's a encapsulated ARP reply. That's what I mean. Okay, VXLAN ARP reply. Is it clear, Raja?
Yeah, got it. So that means it's for the entire group. So it advertises for the entire group. Okay, I got it.
Yeah. What about other folks? Ajay, Ganesh, Sudhamsh, Rohit. Is it clear with everyone?
Yes, Nikhil.
Yep.
It's clear.
Okay.
Nikhil.
Okay,
Yeah,
and okay, great.
clear, Aniket.
Okay, so let's so there is one more type of ARP sync that happens. Okay, we'll see that also. So another ARP sync is if I'm pinging from leaf 1, okay, now I will ping from leaf 1 to host 3. Okay, it will send an ARP request sourcing with VMAC, and host 3 will now send the ARP reply with DMAC as VMAC. And remember, this VMAC is also configured here on leaf 3. So it will consume it, but it will also flood it. So what we'll do is we'll take a TCP dump. We'll take a TCP dump here and we'll ping host 3, which is 100.1.1.200. Okay, this one. So yeah. Oh, come on. So here, if you see, you will see an encapsulated ARP reply. This is a request and this is a reply. It is flooding the reply, if you see, right? How do I know it's flooding? Because there are two copies, two ARP replies. One is going to 1111, another is going to 2222. So this is also flooding. And now if you check the ARP here, it has learned the ARP. Guys, is it clear?
Yes, it is clear.
Yeah.
Yeah, Aniket.
And
Okay.
Aniket, if we want to, take the PCAP at the receiving end, if we want to take ARP replay PCAP at the receiving end of the VTAP, we should not take them directly, right? We should, mirror, or what should we do?
Sorry, ARP reply where exactly?
Receiving end, let's just say one dot in this case, it's sending to ARP reply is being sent to 1.1.1 and 3.3.2. 2.2.4. Let's just say we want to see it at 1.1.1.1. We want to take a peek up at 1.1.
So yeah, that's what. Now I will. We might see it here. Okay, let's try that once again. Okay, I need to. Okay, I'll take it here. Dash. So I'll take a TCP dump here. We will see it here for sure, I think. but yeah, okay, that's a lot of packet. Yeah, so this is the ARP reply. It's coming from host 3. We can see it here. That's not a problem because this is all software. But in hardware, we might not see it. In hardware, I need to check this part, okay? Because in earlier version, what used to happen is, if you take a TCP dump on the uplink, right? By uplink, I mean this Ethernet 4, which is connected to spine. If you just take a normal TCP dump, or if you take a TCP dump on the SVI, okay, you will not see that ARP reply. Okay, let's try it here then. 100. I think we should not see it here. Yep, you don't see it. See, you see the request, but you will not see the reply because that reply is generated by the VXLAN software forwarding agent. So what we need to do is we need to take a mirror on the uplink that is connected to the spine. In this case, everything is software, so I don't have to do a mirror. But if you are on hardware, then you have to do a mirror on this Ethernet 4 and 5. And then you have to see whether it is getting the ARP reply, or there are certain other ways. You can check queue trace, you can check certain counters, okay, like show VXLAN counter var. But in most cases, these counters are useless because it's anyway incrementing. So it's very difficult to kind of isolate for which ARP packet this count is increasing. So it's very difficult. So Qtrace are helpful. Qtrace can tell whether it has got an ARP reply or not. But you saw here, right, in TCP dump in VLAN 100, you see that it is sending an ARP request, but you don't see the ARP reply. After that, you see the ICMP request of the ARP is resolved.
Yes. Because I remember, taking TCP dump on the receiving side of the ARP reply and not seeing packets. So
Yeah. And if you take, but that is for VXLAN ARP. Now, if I do it for a normal ARP,
yeah, normal up we
uh,
can see. Yeah.
like that is connected, locally connected, host 1, that we should see. Okay, obviously. So now I will clear ARP cache and I will ping the locally
Leaf
connected
1.
host 100. Okay, and you will see the ARP reply. Yeah,
Yes.
this is ARP reply, just logged later, but yeah, you can see here, which is missing from here. Okay, so that's the difference. Whenever the leaf gets a VXLAN ARP request, or whenever it has to send an VXLAN ARP reply, that VXLAN ARP reply is always generated by the agent, software forwarding agent, not through the kernel. So you won't see it here. So these are the small key differences, like when you're troubleshooting, you're on call and you did a TCP dump here and you're not seeing the ARP reply. You are wondering, hey, what's happening? Why are we not seeing the ARP reply? Is it not getting? So you need to know that, right? Because if it is a VXLAN ARP reply, you will not see it. Lot of silences, guys.
Is it the
Yeah.
same for ICMP packets as well? Like, let's just say we are pinging from H1 to
Yeah,
H3 and the packets are encapsulated at
correct.
VTAP
Right.
1 and they're being decapsulated at VTAP 3. So we can see them on VTAP 1, but we cannot see them on VTAP 3 if we take a PCAP.
ICMP is different. Okay. So if you see here, what do you see? The source IP is getting natted. It is not 100.1.1.1. So what happens is whenever you have IP address virtual, and if you do a ping from the leaf, the inner source IP is always natted. It is never the virtual IP.
No, I mean, let's just say we are pinging from host 1 to host 3. Host is not, on host we have physical IP, right? It's not virtual IP.
Host 1 to host 3. Okay.
Yeah.
Yeah.
So
It is
my
physical.
question is, you can once you can go to the topology, so that I'll tell my question.
Yes.
So if we're pinging from host 1 to host 3,
Hmm.
and if we take a TCP dump on leaf 1, like VTAP 1 and VTAP 3,
VTEP 1 and VTEP 3. Okay.
Yeah, so in the TCP dump, we can see the ICMP request, like encapsulated ICMP request packets sent by VTEP 1 in the PCAP, but we cannot see the packets that are being received at leaf 3.
Oh, okay, I got your question. So when host 1 is sending ARP request for host 3,
Yeah.
so okay, so see that if host 1 sends an ARP request for host 3, which is in the same subnet, that will be flooded. But if there is no SVI, then it is flooded in the hardware. But if there is a SVI, actually no, that is for EVPN. In VXLAN, it will be flooded in the hardware. So no, you won't see this ARP reply on, you won't see this ARP request on the uplink in hardware. You will see it in VOS, but in hardware, when host 1 will send an ARP request, leaf 1 will encapsulate that in the hardware and it will send it to leaf 3.
Okay. So we won't see
And
it.
but and if you take a TCP dump here on SVI, if let's say you have a SVI here, if you take a TCP dump, you will still not see it. So let me show you one thing, okay? Let's say I'm sending an ARP request from host 2 towards for its gateway 200.1.1.1,
Okay.
which is a VXLAN ARP packet. Let's see if you see that ARP request on SVI, okay? So what I'll do is I'll run a TCP dump here and also on leaf 4. And I'll send an ARP request from host 2. Oh, sorry, this is VLAN 200. You will not see the ARP request here. So what I'm trying to say is any VXLAN ARP packet, any VXLAN ARP, okay, whether it is a request or reply, is handled or is handled or managed or whatever you want to say by VXLAN software forwarding agent and not the kernel interface, not the kernel. Okay, so you will not see the VXLAN ARP packet on SVI 100 or 200. This is what I'm trying to say. Any VXLAN ARP packet, whether it is I showed you for reply, okay? Reply, you saw that you don't see the reply here in TCP dump SVI, and similarly for request also. Request will be flooded to both. Let's take it on leaf 3 as also, okay? Just for the peace of mind. VLAN 200, and we'll clear the ARP, and you don't see it here. You don't see it here. You don't see it here. But is the ARP not resolved? It is resolved.
It is, yes. Yeah, so I'm clear about the ARP part. I'm talking about normal control plane traffic like ICMP or anything. VXLAN encapsulate.
ICMP anyway, it is data plane, right? You'll never see it in.
Sorry, data plane traffic. Yeah, of course.
You'll never see that in TCP dump.
Yeah,
Anything.
but we are going to encapsulate it, right? Like the VTEP is going to
Encapsulation is in
encapsulate it.
hardware. Everything, any data plane encapsulation is in hardware.
Okay, so
It'll
we're
never.
not going to see the encapsulated ICMP packets anywhere on the VTEPs.
No,
We'll see
no,
them
you have to
only on-
mirror. We
Okay.
always have to mirror.
Okay, yeah, that's it.
Mirror which part? I mean, like
Mirror the
the
uplinks.
Uplinks.
Just
uplinks.
Yeah.
Uplinks.
Uplinks. We
Yes.
can't see anything in VX1.
Yeah, it's
No.
like capturing data plane traffic, right?
Okay.
It's capturing data plane traffic. Data plane traffic, we don't see it in software, right? Why I'm talking about ARP is because ARP can go to software. ARP goes to software. That's why I'm talking about ARP. But data plane ICMP and TCP, that is routed in the hardware. You will never see it in normal TCP dump. You have to mirror it.
Okay, suppose if I'm initiating a traffic towards leave one's SVI,
Okay.
if I do a
Then you
TCP
will
dump
see.
on the SPA, I will see,
Hmm.
right?
Then you will see, because it's a
Okay.
ICMP packet which is not managed by
Destined
VXLAN
for,
software forwarding. Yes,
but it's
ICMP packet.
encapsulated, right?
See, VXLAN software forwarding agent, right? This agent only deals with
Yeah.
ARP. Only
Okay,
deals
it's only
with
for ARP.
ARP.
Okay.
Yeah, it doesn't deal with ICMP or TCP or UDP or anything. So a VXLAN ICMP, that you will see, that will go to the kernel. Let me show you. So now I'm taking TCP dump on this, and I will ping, and hopefully the packet goes to that. Anyway, we're taking the capture everywhere. Okay, because we're pinging a virtual IP. So ping 200.1.1.1, and yeah, packet came here, and you can see the ICMP packet, but you will not see ARP. If I clear the ARP, you won't see it. Is it clear, Raja?
Yeah. Thanks, Aniket, for clarity.
Yeah, these are very small differences, that's why it can become confusing. That's why you need to practice. Okay, so I want you to take this opportunity, this challenge as an opportunity to practice all these things and understand these small, minute differences. It's very important in troubleshooting. Okay, better if you can do it in hardware, I would say, because in VOS also you can understand these concepts, right? Like I know why am I not seeing this ARP request in the SVI. That's why I know the concept. That's why I know you will not see it in VOS also.
Yeah,
Anyway,
VOS
oh,
are quite unreliable.
no, VOS is enough to understand your concept. Okay, it's enough. Whatever
Yeah,
I'm
if it
telling,
is
right?
not working, I'm saying I would doubt VOS
Uh,
than the concept, right? So uh, it's like I mean, like a lot of features are very restricted in VOS, right? So yeah, but
so
hardware is best, but yeah, getting the
of
hardware is
course,
also a challenge. Yeah.
no, of course, Raja. But what I'm saying is, until unless you don't know the concept, what's the point of doing it in hardware? There might be some additional benefits of hardware, but whatever you need to learn, you can easily do that in VOS.
Okay.
Okay, there's not a lot of differences between hardware and software as far as the concept is concerned. But if you tell that this feature is there in hardware, so that's correct. And we don't use VOS in production, right? We don't use. We use VOS for understanding. Customers use VOS for understanding, for their own learning.
Yeah.
That's what you're trying
Yeah,
to
they
do
are
here.
using for some of them are
Not
using
VOS Lab. VOS Lab is not.
cloud
They use Cloud EOS.
cloud
That is
UOS.
different.
Yeah, cloud UOS.
VOS Lab is different. Cloud EOS is different.
Okay.
Cloud EOS supports IPsec and everything, so that can be used, but not VOS Lab.
Yeah,
Okay,
Nikhil, I have
so
one doubt here. Maybe I
yes,
don't know if you covered that in the earlier session.
yes.
So in the AppSync scenario, like while using this IP address virtual command, is it mandatory that we also configure VVTAP?
Yes. So Sudham, we have covered this. IP address virtual. Whenever you use IP address virtual, uh, you will have to configure virtual MAC and you have to configure VVTAP.
Okay.
So I will suggest you go through yesterday's training video, okay,
Sure.
where I've explained that.
Hmm.
But I don't want to go into the depth of that because that will take half hour.
Understood. Yeah.
Okay. Any other question about this AppSync? We talked about two AppSync. One is from the perspective of, when Leaf3 gets a VXLAN ARP packet on VXLAN interface, and another is locally. The two AppSync.
I have a doubt. So
Yeah.
we saw that in second case, since the ARP is being initiated from host 3, it does not change the inner MAC address, right? Ethernet.
You mean host 2?
No, on the ping from, let's say Leaf 1 is pinging host 3.
Okay.
In that case, Leaf 3 while ARP syncing, it does not change the MAC address, right? Inner MAC.
No, I mean, here there is no need for sync here. There is no need for changing the ARP reply. See, why will host change ARP? Why will
No,
host
no.
change the inner source MAC?
No, not the host. I'm saying a leaf 3 when it's syncing with
Oh,
leaf
no,
1.
it'll not change. It will not
Yeah,
change.
so can we say that if an ARP reply is sent in any local interface, it will not change the inner header leaf 3, the route, the VTEP?
I think what you should understand is why it is not changed.
Yeah,
Why is because it is correct, right? It is locally connected. Why is there is a need to change that? We are changing it here because the host is not connected on leaf 3. So if you don't change on leaf 3, then leaf
It will
1
be
will
sent
think
to,
that for any traffic leaf 1 wants to send to host 2, it will land
it will
on
go
leaf
to
3.
leaf 3. Yeah. Got it.
That's what you need to understand. Why? Okay?
Yeah. I also have another question. So
Yes.
when in the first case, when you're trying to ping host 2, we saw that leaf 3 was syncing the ARP with leaf 1, right? So why can't leaf 1 do the same with the leaf 2? Again, ARP sync.
Because
So
that
how
is
does
where it came from. That is where it
Yeah,
came
but
from.
how does leaf 1 know where it got initiated from? Can it not again initiate an ARP sync with leaf 2?
You mean how does leaf 1 knows? Oh, you mean why leaf 1 is not initiating an ARP sync?
Yeah, after it
That's
received from leaf
That's a
3.
good question. Okay. Can anyone answer? Can anyone? That
ARP,
answer is there in this page if you read properly.
ARP sync happens only if the ARP reply is destined to the VVTAP. But
Yes.
here, while syncing the ARP, it already changes the destination IP to a physical IP like VTAP IP,
Yes.
so it won't.
Yes, that's correct. So when leaf 3 is sending that ARP sync, right? If I check the previous capture, when it is doing the ARP sync, right? It is sending to the outer DIP of 1111.
Okay. Got it.
And ARP
Yeah.
sync is triggered when the outer DIP is VVTAP.
Got it.
Yeah, good questions, by the way. Any other questions?
Yeah, Aniket, so the last part when if why leaf 1 is not forwarding, it's receiving an ARP reply destined for the physical VTAP, right? So
Yeah, it is getting for 1111. So see here, 1111 is the physical VTAP IP or primary VTAP IP, whatever you want to call. Okay,
right, yeah,
physical VTAP, and 5555 is the virtual VTAP. Okay, so it is getting that ARP reply, the synced ARP reply with the outer DIP as 1111 and not 5555.
okay. Only ARP request is dropped when it is coming for the physical VTAP.
Yes,
Right, okay,
only
yeah,
ARP
all
request
right,
is
yeah.
dropped. Yes, everyone, you should try to make a note of these differences. Okay, yes, that's a good observation, Raja. Only ARP request which is destined to 1111 will be dropped, but this is ARP reply. It won't be dropped. It will learn it. Is it clear for everyone?
Aniket.
Yes, Aniket.
Okay.
Yes.
Okay. Cool.
So like
Yeah.
the ARP request for the only for the virtual IP destined to the physical VTAP IP is the one that is those requests will be dropped. But if there
Yes.
is an ARP request for the physical IP with the physical VTAP
VTAP
IP,
IP, it won't be dropped.
Okay.
It won't be dropped. That's correct.
okay, all right.
Because like the thing is, you should understand it this way, right? A virtual IP can be present anywhere.
Correct.
So you don't want all the routing VTAPs who has a virtual IP to respond. You want only one of the routing VTAP. If they respond with the virtual IP, it's enough. So we are dependent only on the VTAP. So only one VTAP will receive that ARP request without a DIP as 5555. So only that VTAP will respond for the virtual IP. But as far as the physical IP is concerned, then it has to reply because 555, let's say if it is dependent on 5555, then the ARP request destined to a physical SVI IP can go to another VTAP where the physical IP doesn't exist.
Yep.
Okay, all right.
And one more thing is like for when we're talking about like ARP sync. So suppose if we are initiating the ARP request from leaf 3 towards host 3, let's say.
Sorry,
So
come again. I missed that.
so like suppose if we are initiating the ARP request towards host 3 from leaf 3,
Okay. Okay.
right? So
Okay.
in that case, whatever ARP reply comes, that will also be
This
synced, right?
synced. Yes, correct. When leaf 3 sends an ARP request, and host 3 will send the ARP reply back to leaf 3 with a DMAC as VMAC. So leaf 3 will again sync it.
Okay, got it.
By sync, it means flood it.
Yeah.
So this was a mechanism by which we like, because leaf 3 will sync it, because leaf 3 will flood and sync with all other VTEPs, there is no need for leaf 1 to now send an ARP request for host 3. So all other VTEPs are already aware now. So this was the manual way of learning the ARP, like for everyone. Like now we have EVPN and CVX, but before this is how we used to sync. Like we used to send an ARP reply which would be synced with everyone, and that's how leaf 1, leaf 4 could be. Like all routing VTEPs could be aware about the ARP using data packets, but now there are control plane. But yeah, to answer your question, yes, leaf 3 will sync that ARP.
Understood.
Any other questions? Then we'll move it to the MLAC ARP sync part. We'll try to wrap it up by 4:30. Okay. All right. So MLAG, as I told you, right? If you remember, in MLAG with IP address virtual, you will always sync ARP. Like if leaf1 gets an ARP reply, whether it receives it on directly on this interface, or whether it receives it on the peer link, wherever it receives, it's going to tell leaf4. Or if leaf4 gets an ARP reply, it will tell leaf1. So what we'll do now is we will shut this link. We'll shut this link and we'll initiate an ARP request from leaf1, and we'll force that ARP reply to land on leaf4. And remember, the ARP reply is destined to the VMAC, and VMAC is configured here also. So leaf4 will consume that ARP, but it will also sync it with leaf1. So let's do that. So we have MLAG interface, and we will shut port channel 1 here. We'll clear the ARP. Okay, and let's check. There is no ARP here. No ARP. Now, when we'll send an ARP request for host 1, the reply will land on leaf4. And leaf4 will consume it because it also has the same virtual MAC. So the ping may not work. That is fine. But you see this, it's learning the ARP. It is syncing it. Okay. The reply landed on leaf4. Leaf4 synced it with leaf1. And if you see this counter, show VXLAN counter for the VXLAN ARP cache received from MLAC peer. Let's see if this counter increments. It does. Okay. I hope this part is clear.
Yeah, yes, Aniket.
Yes, Aniket.
Okay. Now, next thing we'll do is we will force the ARP reply. Actually, I don't want to do that. We're running out of time. But just know that even if the ARP reply, like let's say I'm pinging from leaf1 to host 3, and the ARP reply lands on leaf4, the ARP reply lands on leaf4, Okay, leaf 4 will learn that, and then also it will sync it with leaf 1. I'm just not showing that, but that is also true. Okay. All right, let's just quickly cover VARP. We don't have a lot of time. So what we'll do is we'll change this to VARP. So first we'll give a physical IP, and then we'll give the virtual IP. Oops, I need to remove that. And the first thing I'll show you is the MLAG ARP sync, okay, on VARP. And let's configure this. Okay, we'll just do it for one VLAN only. I'm not changing it for VLAN 200. So now, if you remember, I told you yesterday in VARP, there is no MLAG ARP sync. Okay, and how do we validate that? The port channel 1 is still down here. This is down. So now we will send an ARP reply from leaf 1, and the source MAC will be now physical MAC, because in VARP everything is physical. Okay, so we'll take a TCP dump on host 1 also. Port channel 1. Okay, so we will send an ARP request from leaf 1, which will go to leaf 4, and then will reach host 1. And host 1 will send the ARP reply destined to where? To which MAC? Come on, anyone?
Physical MAC of leaf 1, there is no virtual here, right?
Yes. DMAC is going to be leaf 1. Okay. And what will leaf 4 will do? It will bridge it, right?
Yeah.
Okay. Leaf 4 will not learn the ARP, okay, because it is not destined to its own MAC. It is destined to its peer MAC. So it will bridge it. So let's see that. Yeah, ARP should not be learned anyway. Yeah. So now I will ping, and the ping will also work, you'll see, hopefully. Yeah. Now you would see you have the ARP here, but you won't have it here. There is no ARP sync. And that's fine. That is fine, because now if I ping from here, it will still work. But if the same ARP sync doesn't happen in IP address virtual, then that's a problem. So in IP address virtual, you have to do the ARP sync. But in VARP, because the ARP reply comes back to you who have initiated the ARP request, you will always learn the ARP. Is this clear? And yeah, let's take the TCP dump. If you see in the TCP dump, the ARP request, this is the ARP request, and you will see it's coming from physical MAC. Okay, and the reply is also going to the physical MAC of leaf 1. And similarly, let's see this also. Similarly, now what I'll do is I will shut down the uplink on leaf 4, okay, and I will ping from leaf 1 to host 3. So the ARP reply will land here. Okay, the ARP reply will land on leaf 1, and it will still not sync it with leaf 4. Okay, so what we'll do is we'll shut down Ethernet 5 and 6. So it doesn't have any uplink towards spine now. So any ARP request that leaf 1 will send, the reply will come back to leaf 1 only. And yeah, is someone saying anything? Sorry, 100.1.1.200. You will see you have the ARP here, but the ARP will not be here. It doesn't sync.
Yes. We were pinging the gateway, is it? Sorry.
We are pinging from leaf 1 to
Yeah,
host
leaf
3.
1 to host 3, correct. Okay, yeah.
Okay, so here the DMAC is leaf 1's MAC. And what happens is, why I shut down this uplink on leaf 4 is because when leaf 3 will encapsulate, right, it will put the outer DIP as 111, right? And 111 is present on leaf 4 also. So the reply could come back on leaf 4.
Yes, so that's why we removed that link. Okay.
So I force that ARP reply to come on leaf 1 and still it doesn't sync. But this will not happen in IP address virtual. Like in IP address virtual, if you get the ARP reply in leaf 1, it will sync it with leaf 4. Okay, let's just quickly test that. We have interface VLAN 200, right? Okay, so I will ping host 2 from leaf 1 to host 2. Okay, and you will see the ARP sync happening. Now the ARP reply has to come back on leaf 1, right? Because this uplink is down on leaf 4.
We might see it on leaf 4 as well, like you said.
No, you won't see it. Oh, sorry, you will see it. Sorry, yes, it's IP address virtual, right?
Yes,
You will
yes.
see it. So 200.1.1.100. Ping will not work because source IP gets natted.
Mhm.
You will see the ARP here. Why is it not learned? Because it's sync. And you will see the ARP here also.
Okay.
You see how the behavior is different, right? For VARP, when you're getting the ARP reply, you're not syncing it with leaf 4. In IP address virtual, when you're getting the ARP reply, you're syncing it with leaf 4. Everyone, is it clear? This is very important.
Yeah.
Yes, Aniket, it's clear.
Yes, so Aniket, this MLAG situation, it would have black holing, something like a black holing here, right?
There will be no black holing.
Because the
There will
ARP
be.
is not going back to the host here, right?
See, in VARP, in case of VARP, the
Yeah,
request
in
is
case of
generated
ARP.
from the physical MAC. The request
Okay.
is so let's say what will happen if the ARP is not present here? What is the worst that can happen? It
Can
will
you go
send
to
an
the
ARP
diagram?
request. So what I'm saying is,
Yeah.
let's say on leaf 4,
Yeah.
and I'm talking about VARP. Let's say I'm pinging from, and let's bring this uplink, okay?
Okay.
Let's say from leaf 4, I'm pinging host 2, okay? And I'm talking about VARP. In VARP, the request is generated with the physical MAC. Okay, so
Right.
will this ARP reply ever go to leaf 3?
Leaf 4, it will go to host 3. We are pinging host 3, right?
I'm pinging from leaf 4 to host 2. Leaf
Host
4
2.
is sending
Okay.
an leaf 4 is sending an ARP request, sending ARP request for host 2. Okay, with
Okay.
source MAC as own MAC, own physical MAC.
Physical MAC. Okay.
So to where host 2 will send the reply. Host 2 send ARP reply destined to where?
Leaf 4.
Leaf 1, right? I'm pinging from leaf 1. See, we are pinging from leaf 1, sourcing.
Okay.
It's sending the ARP request source with the physical MAC of leaf 1. So host
Okay.
will send the ARP reply destined to where?
It will send to VV tab, right?
Why leave it?
111, 333, and 555.
Raja, host 2 is sending the ARP reply, right? If I take a capture on
Right.
host 2, it sends an
Correct,
ARP
yeah.
reply. In that ARP
Correct, yeah.
reply, what will be the Ethernet destination MAC?
Ethernet destination MAC will be the leaf one's MAC.
Yeah, that's what I'm saying. It will be leaf one's MAC. And where is leaf one learned? On which VTEP it is learned?
Okay, it will be learned from 111. Okay. So it won't flood it. Okay.
It won't go to 555. It will come back here. Now, let's say that ARP reply, instead of leaf 1, it comes on leaf 4.
Okay.
Okay, because 111 is present on both leaf 1 and leaf 4. It can come on leaf 4. But leaf 4 will, what will it do? It will see the inner DMAC.
Yeah.
It will see that the
Yeah,
DMAC
it
is
will
leaf
bridge
1's
it.
MAC.
Okay.
It will send it to leaf 1. So what I'm trying to say is there will never be a situation where leaf 1 is unable to resolve the ARP for remote host. Because it is sourcing that ARP request with its own MAC. So it will always get the reply back to itself.
Okay.
So there is no need for sync here. It will always get. Why are we syncing in case of IP address virtual? We are doing the sync because that ARP reply may land somewhere else. And if that device doesn't sync it with the originator, then there is a black holing. Okay. So in IP address virtual, if the ARP reply lands on leaf 4, leaf 4 will learn that ARP. But if it doesn't sync it with leaf 1 will not learn the ARP. And neither it will send that ARP reply to leaf 1 because it's destined to itself.
Aniket, I have a doubt.
Yeah.
So in case of uplink, let's say if it's an MLAG port channel, would it be using the common MAC address or individual
These
MAC?
are layer 3 links, okay? These are layer 3. But
okay, if let's say if it's an MLAG port channel,
then your underlay is via SVI. I mean, everything is changing here. See, if you make right now, if you see here, this is Ethernet 2, right? Sorry, Ethernet 4, which is a no switch port. If you say MLAG interface, it will become switch port. Like it will be layer 2. And if you
so
make
in that
it layer
case,
2,
so in that case, my question is the MAC address used would be the common MAC address, right?
no, it will be physical MAC for VARP. And MLAG, right? Only the layer 2 is same, but layer 3 is their own. From the layer 3 point of view, leaf 1 is on its own. So when it sends a ICMP packet or ARP packet, it will send it with its physical MAC.
Okay.
And that you don't need to make the uplink as MLAG port channel. Just look at here. If you see the downstream MLAG port channel, right? This is also MLAG port channel, right? This is MLAG port channel 1. So when it sends ARP request, leaf 1, when it sends an ARP request, then the source MAC is what? Source MAC is physical MAC, right?
Yeah.
Let's see that. Okay, so let's make it IP address virtual again. Oh no, sorry, this is VAR, correct. So we'll take a TCP dump here. I'm pinging from leaf 1 to host 1. And this is the ARP request coming from leaf 1. And what do you see? This is physical MAC. I'm taking the capture on host 1. On host 1, the ARP request is coming from leaf 1. This is MLAG port channel. And host 1 is getting the ARP request with the source MAC as physical MAC of leaf 1.
Okay. Got it. So this one is CARP, right?
Which one?
This that you just highlighted.
No, this is ARP request. In GARP, what you will see something like this reply, but this DMAC will be broadcast. Let's just keep it running. Okay, you should see that GARP somewhere. For example, we have it. Yeah, like this one. This is a GAR packet. It's a reply, but DMAC is broadcast.
Okay, got it.
Yeah, Aniket, I just have
Yeah.
one query, which is from the bridging VTAPs. The MAC is, I mean, like uh, the MAC address learned from the other routing VTAPs. Say, for example, it would be synced here, right? Whenever there is a communication, it would be MAC address will be learned here in the bridging VTAP here, right?
What do you mean? If leaf to
Say,
receives
for
a packet,
example, yeah, if the say for example, host 2 is pinging to host 3, and leaf 2 initially it would I mean, like initially for our perspective, it would flood the packet initially when there is host 2 doesn't have the R. For host 3, it will initially flood the packet, and once leaf gets this packet, it would flood to the VVTAP 5.5.5.5 in both the
it's
ports,
not
right? It
flood.
will do the
Yeah,
flooding.
unicast. No, it's not flooding. It's unicast. Yeah, right. It's ARP request. Yeah, it will flood it to all the three IP 111.333.555. Yes.
Yeah. Okay. So one. Yeah. So now uh, goes to spine 2, and I mean, like the once the host replies, it comes to, I mean, like the in leaf 3 it would send a unicast to leaf 2, right? Leaf
So
2
you're pinging
VTAPs.
from host 2 to host 3, is it?
Host 3, yeah.
But you talked about ARP request, huh?
Yeah, initially
Host
the first ARP resolution takes place, right? So first host
okay,
2
the
will send
ARP.
the ARP.
So ARP is learned, you mean?
No, ARP is not learned initially. So initial packet, it will initially go for ARP request, right? To host 3. Packet will be initiated. Say for example, the first time device is brought up, and
No,
host 2
I
is
got,
trying.
I understood.
Yeah,
What I'm saying is you are sending from host 2, you're sending the ARP for your
correct.
gateway, right?
No,
Not host 3.
to host 3.
Host 3 is different subnet.
Okay,
Or
sorry. Say for host 1, same
okay,
something in same VLAN, something
okay,
in
let's
same
make
VLAN.
it same subnet. Okay, so
Okay,
let's
yeah,
say 200.
yeah. So
Yeah,
in
now
that
tell.
case, initial packet will go as a I mean, like host would initiate a broadcast, and leaf will initiate flooding to 5.5.5, if I'm right.
Yes.
Okay, and 1.1.1 and 3.3.3, will it also be initiated here?
See, whenever we are flooding, right?
Yeah.
There is no discrimination here. It will flood
Okay,
everywhere.
it will flood everywhere. Okay, it would flood
It's
here.
not like I'll
Okay,
flood to this and I'll not flood to this. It's not like that. When
okay.
it floods,
As
it
per
floods
flood list, it
everywhere.
will flood it. Okay.
Yeah.
And if and once the packet reaches leaf 3, yeah, leaf 3 it will goes to
Host
host 3,
3.
and then host 3 is reply backs
Yeah.
leaf 3,
Then
and leaf 3 would
DMAC will be host 2. Yeah.
yeah, and leaf 3 it would send a unicast, or
That
it
you
will
should
again
be
flood.
able that you should answer, right? What will happen? So DMAC is host 2, okay, and of the ARP reply packet. And
Okay.
where is that host 2's MAC learned? Behind which VTEP?
It's bridge 2222.
So why will it be flood or will it be unicast? Will it be
So
flood or will it send it to 111 also?
like ideally it doesn't require, but I'm just thinking, I mean, like having it out because of it's a bridging VTAP. So
No. This here the DMAC is host 2's MAC. This is not VMAC. Only if it was
okay,
VMAC, then it will be flooded.
okay, okay.
Yeah, this is simply bridging. Like if you just talk about normal switching also without VXLAN, that's
Okay, any packet which is coming from this
uh,
it will be learning as this MAC is learned from this interface kind of a thing. So similarly, we
Yes.
are learning it as from the from 2222 it will be learned, so it will go as a unique as say for example in leaf 3 there is the MAC is not at all learned, okay,
Hmm.
and we are initiating ARP is there for host 2, okay, every time it will flood it, right, in this scenario.
You mean the host whose MAC is not learned?
Correct.
Then
No,
it will
host
flood.
2's ARP is host 2's MAC is not learned, ARP
Even
is
in the
learned.
MAC address, ARP is learned. In the MAC address table, the MAC is not learned.
Correct.
Yeah, then it will flood unknown unicast.
Okay.
And that will
So,
happen in this scenario very easily. Very easily. You can think of it, how it can happen, but it will happen. Like if you ping from host 1 to host 3, after some point, you will not see the MAC address of host 3 learned here. And on leaf 3, you will not see the MAC address of host 1 learned here.
okay.
And then what will it do is it will always flood it. Like any packet leaf 4 sends to host 3 will be flooded. It will reach leaf 2 also.
Okay. So that's where the CVX part comes into the
Yes,
picture.
that's where
Okay.
CVX CVPN comes.
But on even in CVX also, if the MAC is not learned, say server is like server's MAC is not learned, then it would always flood again. The same
That
in
is
whatever
the
scenario, MAC is not learned, it will go for a flooding,
yeah
unicast flooding.
that has to happen, right? If a MAC is not even learned, like let's say host 3's MAC is not learned on leaf 3, then leaf 3 will not tell to CVX. And these leaves, leaf 1, leaf 4, they will not learn about this host 3's presence. And then leaf 1, leaf 4 will always flood it. But this will never happen because as soon as leaf 3 learns that MAC address of host 3, whenever it gets a packet, leaf 3 will learn the MAC address of host 3 and it will tell it to CVX.
Okay. But it get aged out, right?
It will age out without CVX. That's what I'm saying. Yes.
With CVX also, the MAC address will age out, right? Or with CVX will it mean like will retain it after even after the MAC aging time?
No, Raja. So here, if as long as host is sending a packet, why will it age out?
Yeah, I'm saying okay. If it's okay, the initial packet alone will get flooded, and afterwards it would be a unicast is what you're saying.
As long as host 3 is sending a packet, leaf 3 will
Okay.
always learn the MAC. As long as the
And
MAC is learned, CVX will know. CVX knows, then these leaves also know.
will also know. Okay.
But without CVX, what can happen is this MAC, although host 3 is sending packet, although the MAC address of host 3 is learned on leaf 3, it might not be learned on leaf 1 and 4.
Okay.
But that won't happen with CVX. Okay.
Yeah. Thanks.
Okay, so yeah, that's very good discussion. We are way ahead of our time. Any other questions? And I would suggest that maybe whenever you get some time, just go through this recording again, because this small minute things, it can confuse you because I might have gone a little fast somewhere. So if you just go through the recording again, pause and play, then you'll just learn it again, and then you can ask questions again later. But for now, I hope you got some idea. If you're a little bit confused, it's fine. Just just do a packet walkthrough every time. Just do a packet walkthrough. Just remember those rules I told you. Okay, this rule. When does a ARP sync happens? Okay, remember these rules, and then you should be able to connect the dots. Any questions?
Yeah, I have one question. Like when leaf 4 syncs it with does an ARP sync with leaf 1, it will again change the Ethernet source MAC to its own MAC, right?
In which case, who is sending the ARP reply?
So we suppose like we are pinging from host 1 to this ARP request from host 1 to sorry, we are sending the ARP request from let's say
Leaf 1.
4 to host 3, right?
From
So
leaf 4 to host 3. Okay.
and this is like the IP address virtual case.
Okay.
So leaf 3 will do an ARP sync
Sync.
with
Yes.
everyone else.
Correct.
So leaf 4 gets it, and when leaf 4 oh, okay. So leaf 1 yeah, so suppose the ARP sync gets to leaf 4. So leaf 4 also has to sync the ARP with leaf 1, right?
Correct. Yes.
In this case, it'll
It won't.
again change the Ethernet source
No.
MAC to its own.
No, it won't change, because what happens is in MLAG we also sync the MAC address table. So when this ARP reply from host 3, when it lands on leaf 4 will immediately learn the MAC address of host 3 behind 3333,
yeah,
which is leaf 3. And this will be synced. This MAC address will be synced. This MAC address will be synced with
leaf 1. Yeah.
with leaf 1. So there is no need to change the ARP reply, because why will you change it? Another thing is on peer-link, you don't learn MAC address. MAC learning is disabled on peer-link.
Okay. Yeah, then okay. Yeah, then there's no flap or anything. Yeah, it makes sense.
Yeah.
Correct. Yes.
Yeah.
Okay. Perfect. Yeah, got it.
Okay. What about other questions? What about other guys? Ganesh, Ajay, all clear?
Yeah.
Yeah, sir. Aniket, all clear.
Good. Anyone else? Okay, then I will stop this recording.